Hello everyone, my name is Daniel Honovic. Thank you for watching my presentation for my Capstone project as part of the Mallet program at Empire State College. The first thing here that we're going to look at is the audience for this project. So I work at Hudson Valley Community College in the ECM program, so I used one of my courses to pilot part of this project, which is the ECMN program, is the Electrical Construction and Maintenance program. And specifically, the courses are ECMN 205 and 215, which the students learn about electronics, industrial electronics, and automation. Some of the project design and goals. So I wanted to create a flipped classroom where students can have digital media to watch prior to coming in for labs and instruction. By doing so, I created a scaffolding design that will build on the basics of AC and DC circuitry and lead them into advanced PLC functions. I aim to help students better understand the content and succeed in the course. The universal design concept and flipped classroom or hybrid course design. I used a lot of OERs, which are open educational resources. And then ultimately, I'd like to try and build a, a community of practice through collaborative working in and out of the classroom for my students. I'm going to assess students on problem-based learning and project-based learning as well. This will allow for a dynamic evaluation of students' understanding and skills as we move through the course. The scaffolding lesson design is used to provide using prior learning assessment to see where we're going to start out at, and then ultimately the students will work together for that so that they'll get to know each other and kind of help each other learn where we should start off as a class. Some of the topics are going to include semiconductors, which will lead us into single-phase and three-phase rectifiers. We're going to build a circuit board, and then the assessment of these topics will be done through labs, lab reports, and project-based evaluation of their circuit board. That will happen at midterm. For the backwards design concept from my lesson plans as well as this project, is the template I used is right here. A lot of the information I took out of it so that you can actually see the full template. Using Bloom's taxonomy, digital planning verbs help me understand and engage, actual learning objectives that students will be able to identify and use in the classroom, such as, trying to validate the circuit operation, taking measurements with actual digital multimeters, as well as designing circuits and constructing circuits as well. One of the e-tools that I use, and there's going to be several that I'm going to talk about. So Twinery is a great e-tool that I used for mind mapping. This helped me basically lay out the entire project, all the coursework, all of the lesson plans and objectives for those lesson plans. So I highly recommend using something similar to this when you're trying to create a project like this as well. Some of the other e-tools that I use, I feel really comfortable using Screencast, YouTube. I use Google Sites as a portfolio site. I'm going to use Google Forms as part of this course to get some feedback from my students. I was toying with the idea of using Zentation, but didn't really fully have a successful experience using it, so I stuck with the Screencast-O-Matic. And then ultimately Blackboard, which was my LMS. This is a look at the actual Blackboard course. So in the announcement section, students will initially come here and they'll see an announcement where I create a welcome video that walks them through how to navigate the Blackboard course and access some of the information. One of the things that I specifically point out to them in my welcome videos is the course schedule, which is in the course information tab. And there they could see the outline of this semester essentially. My video library for my YouTube channel is pretty expansive at this point, and I'll create videos, put them in YouTube, and then also put those links in my Blackboard course, so it's very easy for students to navigate and find. Some of the research that I've done surrounding this topic, I found out that many times in many different areas. So one research portion that I found was from students in Canada. Another one was from students at RIT, where they typically with engineering especially, or not so much English classes and things like that, but with hands-on coursework, which is basically what I teach, it's very hands-on based learning. Students have experienced using digital media say that it's 80% better for their learning experience than not having digital media. But some things to consider when we're talking about this is what the video length is specifically. You'll notice that most of my videos from my digital media are less than 5 minutes. And again, research shows that people that watch videos longer than 3 to 5 minutes typically start to lose interest. So I'm going to try and keep this one short as well. And then the quality and the reliability of the source where that media is coming from. So for creating your own stuff is a lot more reliable than just finding random YouTube videos or finding random information digital media wise and implementing that in your coursework. And then some of the other things to consider is the privacy for both yourself, your students, and then also your institution. And then that leads you into why does privacy matter? Because first of all, you can expose the institution or the students or even yourself to cyber criminals that might try and hack into your personal computers or your personal accounts. So those are all things to consider when using digital media in a classroom. The opening lesson for the overall coursework is going to be a review of AC theory, where we do the PLA, or the prior learning assessment, or prior learning check rather. We're going to try and make this into a group project so that students hopefully come together and get to know each other a little bit better. And this ultimately will help me gauge the classroom and adjust my lesson plans right from the get-go. The COP or community of practice is something that I'm really hoping to get going for the further projects and as well as this one, but it didn't really come through for it. So 2 parts of the overall course. So we're going to go through and we're going to break down. The first portion of it is from the first week of the semester up until midterm. So we're going to do all electronics, and at that point the students will be going through several labs, several lectures as well, and the labs and the lectures will tie together. The digital media will hopefully help them, and when they come to lab, they'll be expected to construct a functioning circuit, basically commission that circuit by turning it on, and then verifying for function by taking digital multimeter readings for voltage, current, and things like that surrounding Ohm's law. Ultimately, they're going to build a circuit board, and that will be one of the assessments for that portion of the class. Next, they're going to go through similar goals for labs and lab reports for the automation equipment, and the summative or formal assessment for that will be at the end, where they need to build a functioning HMI screen. Here's a look at one of the topics that we're going to talk about, the circuit board. Ultimately, we go through, and this is actually a screenshot from one of the videos I created, where I explain the circuit to them and give them different layout ideas. So diodes and DC circuits. Here students will learn about diodes and how they work in DC powered circuits, which is the base level of how diodes function. Essentially, they work like a check valve. They only allow current to flow in one direction, and their bias is determined on the voltage applied to them. Beginning with the single-phase half-wave rectifier and building into full-wave rectifiers, students will begin to build on prior knowledge. Students will complete online tasks such as circuit calculations and also lab reports. This will help them apply a theory to situations and scenarios with the hands-on learning. In the beginning of the circuit board building, students will be able to review information through digital media that will help explain the design and then ultimately bring them up to building the circuit board. So the evaluations will be as such. Students will be evaluated in various phases. Their ability to complete labs in class will be evaluated. Writing lab reports will be evaluated as a separate grade to that. And then meeting digital learning environment and participation requirements, where they're going in and submitting those pieces of information through the LMS to then be graded. The scaffolding lesson design for automation will be similar to the digital electronics, where they're going to first learn the terms associated with the manufacturing system or the PAT system, and then building on this, they will be analyzing and investigating the parts, pieces, and physical layout of the system, and doing a schematic drawing of the system as well, which we call a P&ID diagram. Once they go through that basic learning levels, then we're going to start getting into the automation equipment, which is the PLCs, the VFDs, and the HMI screen. Here I collected some data that shows that this course design with the flipped classroom and implementing digital media was pretty successful for me as well. This is the evaluations of the students through the first half of the lab, and it shows here that obviously they did really well. Most of them passed the class with an A. Most of the grades were higher than an A, and most of the student feedback, which was pretty much verbal, was positive. The evaluation for automation, students will be evaluated in the various phases, similar to the circuit board stuff or the the electronic stuff, where they're completing in-person labs. They're doing lab reports, and then they're submitting that online. And I would like to implement for this as well some form of community of practice. I'm just not sure how it's going to happen yet. All right, the final assessment for the electronics. This is basically a breakdown of that. Ultimately, they're going to construct their own circuit board, and then we're going to grade it by checking it for functionality as well as craftsmanship. The HMI screen building, this final assessment will be similar, where we'll go through me with the students and check for functionality and overall layout and course, program design, which they will be walked through with several labs prior to being asked to do this. But this will be more of a final project where they're expected to be able to complete this on their own. Some of the improvements that I really try to focus on, number one, myself. Some of my personal improvements is being better at articulating my ideas and putting them into action, essentially. And then also stronger planning, better organizational skills as far as actual layout, actual construction of the project. And then the course design improvements, a little bit more of a universal design. I have had students that struggle to access the LMS and not really sure what to do. So I got to try on my end to make that easier for them. And then also implementing some form of a community of practice. I toyed with the idea of possibly using social media. I myself don't have any social media, but if I did form something like that, I'm sure I'd have to ask the institution, how I should go about it and what the rules and regulations are surrounding having, a social media page specific to representing the college. Student success improvements, more accessible and understandable course design and student engagement. So, trying to make it a little bit more exciting for them to actually want to get in there and form the community of practice and do things outside of the classroom together. And then ultimately the department improvements. I'd like to see if my colleagues essentially, or even my department head, would like to try and implement this as a universal thing for all courses. Since we are mostly a hands-on curriculum, it's hard to get away from that. There is no supplement, in my opinion, for hands-on learning, but trying to enhance that learning by using digital media is what this project ultimately was about. And I think it has been successful, and with better construction and better design on my end, hopefully year after year things get better for my coursework as well as my students. Here's a page with some of the references that I have, and thank you for watching my final project presentation.